again, just like any of the assignments, make sure that you have attempted the problems before you work use the video to see how it's done, because if you don't try the problems and you just watch the video, you're going to remember about 10% of what I go over. If you try the problems in advance and then watch the video, if you're not sure, you're going to remember a heck of a lot more. Okay, and then that'll help you because I believe you're going to be using synthetic division and long division for a while, not just in this section, but in some of the other sections as well. So we'll start with long division here. We are to divide 2x squared plus 10x plus 12 by x plus 3. Now, here's what I want you to do. I want you to think of this as a regular old division problem. Put your division sign. You're dividing by x plus 3, so that goes on the outside. You're dividing into 2x squared plus 10x plus 12. Now, the good news is both the divisor, that's this part, and the dividend, that's this part, are already in descending order. If they're not in descending order, you have to rearrange the terms. You x to the second, x to the first, x to the 0. X to the first, x to the 0. You want both the divisor and the dividend in descending order. And if you're missing any terms, you're going to put placeholders in. Now, this one doesn't have any terms missing. So when we get to an example that does have terms missing, I'll kind of point this part out again about the placeholders. So try this long division problem. See what you remember from your Algebra 2 days, because you did do this in Algebra 2. And then if you get stuck, you can watch this part of the video, or you can YouTube another video on long division of polynomials, and you can see if that helps you to get going on this. What times x of x plus 3 equals 2x to the second? You look at the first term of the divisor and the first term of the dividend. You say, what times this term gives me this term? Well, what times x gives me 2x squared but 2x? 2x times x is 2x squared. So the 2x goes up here in the answer or the quotient, but I don't put it above the first term. I kind of like to keep my like terms lined up, so I'm going to put the 2x right there. This is just like regular division. How many times does 53 go into 175? You put the number up at top, and then you multiply underneath and subtract to see if there's any remainder. So now I'm going to multiply 2x times x plus 3, and that's going to be to distribute. 2x times x is 2x squared. 2x times plus 3 is plus 6x. All right, now this is where you subtract. Now, this isn't going to be that tough to subtract because everything's positive and nice and neat and everything's lined up. X squareds over x squareds, x's over x's. But I would think that you might want to try to get into the habit, instead of trying to figure out a subtraction, especially if there's a lot of negatives, think of it as adding the opposite, which means I'm going to change the signs down here of what I'm subtracting so that I'm adding the opposite. So this becomes negative and this becomes negative. Notice I used the red pencil there to kind of emphasize that. Now I add straight down. A positive 2x squared and a negative 2x squared is 0. I'm not going to put a 0 down. You don't need to. A positive 10x and a negative 6x is a positive 4x. And then you have done everything that you need to do. You've done the division, you've multiplied, you subtracted, and now you bring down. In this case, I bring down the plus 12. I start the whole process all over again. Start with the first term, start with the first term. What times this first term gives me this first term? Well, what times x gives me 4x? That'd be a 4. So I put a plus 4 here because it's positive 4. See how my like terms are lined up? Then I multiply, not by the whole thing, just by the plus 4, the positive 4. And again, it's distributing, so 4 times the x is 4x. 4 times the plus 3 is plus 12. This looks like this is going to come out with a 0 remainder. So again, this is where I normally would subtract, or I add the opposite. So I just change the signs if I want to add the opposite. This is 0, this is 0. Now you can put 0 down if you want to here to represent your remainder, but you're not going to put remainder 0. You're going to leave your answer here as 2x plus 4. That is your quotient. That's your answer. That's what you get when you do the log division. Now you're working every other odd number, so the next problem up is problem number 11. In problem number 11, they want you to divide x plus 3 by x plus 2. Now, yeah, that looks weird, but that's what we want to do here. So this is what you're dividing by. That's the divisor. That goes on the outside. This is what you're dividing into, is 7x plus 3. That goes on the inside. That's your dividend. Now, they have the same degree. They're both degree 1, so this isn't going to be much of a division. But you can divide. As long as the degrees are even, you can divide. It's only when the degree of the dividend is smaller than the degree of the divisor, that's a problem then. You can't divide. So you go through this process like I did up here. What times x gives me 7x? Well, that would be 7, positive 7. So I'm going to put a 7 right here. Notice how I line up my like terms. Then I multiply 7x plus 14. Then I subtract, which is the same as adding the opposite. So I change the signs. They're both negative now. These are going to cancel. A positive 3 and a negative 14 would be a negative 11. Now, how does he want the answer? Well, I didn't really look, but I'm imagining that he wants your answer with the remainder written as a fraction. Now, I probably end up being wrong when I say that, but it doesn't look like it. It looks like he's having you write it as a remainder as a fraction. So here's what we're going to do. My remainder is negative 11. You say, well, how do you know it's your remainder? Well, the degree of this is smaller than the degree of what you're dividing by. This is degree 1, this is degree 0. There's nothing left to bring down. That's also another clue. So this is my remainder, minus, or negative 11. I'm going to write minus 11 over my divisor, x plus 7, x plus 2, excuse me, x plus 2. That's my answer. Now, I know some books, they will write 7, comma, capital R for remainder, and a negative 11. That's not very mathematical. I mean, I know what it means. It's just a shortcut. This is what it means. So you might as well write down what it means. I'm sure that's what the teacher is asking for. So that one's done. All right, the next one up would be problem number 15. In problem number 15, you have x to the 4th plus 3x to the 2nd plus 1, all divided by x to the 2nd minus 2x plus 3. All right, when they write the division as a fraction, the denominator is the divisor. This is what you're dividing into, this is what you're dividing by. So I'm going to put the x squared minus 2x plus 3 on the outside of the parentheses, and then I'm going to put my numerator on the inside. Here's our first example where they skip some terms. Now notice that my divisor, x squared, x to the first, constant, is no terms are skipped, and it's in descending order. My numerator here is in descending order, but there's no x cubed term. There's no x term. There's an x to the 4th, an x to the 2nd, and an x to the 0, the constant term. So I'm going to put in two placeholders, one for the x to the 3rd and the other one for the x. So I'm going to write x to the 4th plus 0x to the 3rd plus 3x squared plus 0x plus 1. These are just equal to zeros, because 0 times x is 0 and 0 times x cubed is 0. They're just placeholders to keep everything lined up when you divide. And we can start the process here. What times x squared gives me x to the 4th? Well, x squared times x squared is x to the 4th. So it's 1x squared, or just x squared. Notice I line up my like terms. Now when I multiply and I distribute, I have to multiply times all three terms, so I got to be careful. X squared times x squared is x to the 4th. X squared times minus 2x is minus 2x to the 3rd. X squared times plus 3 is plus 3x squared. Here's where I would subtract, but as I've mentioned a few times, I prefer to add the opposite. So I'm going to change the signs. This becomes negative, this becomes positive, this becomes negative. And then I add straight down, these cancel. I have 0x cubed and a positive 2x cubed, that's 2x cubed. I have a positive 3x squared and a negative 3x squared, they cancel, that's just 0. But since I'm trying to keep everything lined up, I'm going to write plus 0x squared. Then I bring down plus 0, x there anyway. So I start the process all over again. It looks weird, but that's what you do. What times x squared gives me 2x to the 3rd? What times x squared gives me 2x to the 3rd? Well, it'd be 2x. So a positive or a plus 2x goes here, and then I distribute. 2x times x squared is 2x to the 3rd. 2x times minus 2x is minus 4x squared. And 2x times a plus 3 is a plus 6x. And so again, this is where I'd subtract, but I'm going to do this by adding the opposite. So I'm going to change the signs and add straight down. That becomes negative, that becomes positive, that becomes negative. You can really see it well if you use a colored pencil there. Okay, so be careful if you go about this way. These cancel. 0x squared and 4x squared is 4x squared. 0x and a minus 6x is a minus 6x. And then I bring down the plus 1. This is taking 3 steps because still what I'm dividing into has degree greater than or equal to in this case, what I'm dividing by. So what times x squared gives me 4x squared. Well, that'd be 4. So I need a positive or a plus 4. 4 times x squared is 4x squared. 4 times minus 2x is minus 8x. And 4 times a plus 3 is a plus 12. So again, this is where I would subtract, or as I've done many times already, I change the signs and then I add straight down. These cancel. I get a negative 6x, a positive 8x is 2x. A plus 1 and a minus 12 is a minus 11. That's my remainder. Sometimes the remainder is more than just a constant. In this case, it's a binomial. But notice that the degree of this is 1 and the degree of what I'm dividing by is 2. So as long as the degree is smaller than the degree of the divisor here, that's your remainder. So it's a positive 2x, so I'm going to write plus, and then I'm going to write 2x minus 11 on top, your divisor on the bottom, x squared minus 2x plus 3. So that's a much longer answer there, compared to the first two at least anyway. And that's how you're doing long division. Do we have one more? Nope. Now we're going to switch over to synthetic division. Synthetic division is not that bad. It is a little different, but it's not that bad, and it goes faster than this. But you can only divide in synthetic division if you're dividing by a linear, like here. Oh, like here. I could use synthetic division here. I couldn't use it here because I'm dividing by a quadratic. It has to be a linear, like the first couple of problems, 7 and 11 there. It has to be a linear, and you want the lead coefficient to be 1. See how this is 1x here? You want that to happen. I'll show you what happens if he gives you examples when you don't have that, but that's what you want to have happen. So in problem number 19, you're dividing 3x to the third minus 10x to the second plus 12x minus 22 by x minus 4. Okay, now, your divisor has to be in the form x minus the number. So the number, see x minus 4, x minus the number is 4. So what you're going to do is you're going to put a little pocket here, and you're going to put the 4 in there for the divisor. Now you say, no, it's minus 4, it should be a negative 4. No, it's always kind of the opposite of what it looks like there. Now, what goes out here that you're dividing into are the coefficients of your dividend. You've got a positive, now notice descending order, no term skipped. No, I don't need any placeholders. X to the third, x to the second, x to the first, constant. So I'm going to write just the coefficients in the constant term. I'm going to put the 3 from the 3x to the third. I'm going to put a negative 10 for the minus 10x squared. I'm going to put down a positive 12 for the plus 12x. And I'm going to put down a negative 22 for the minus 22 there. Then I leave a little bit of a space underneath so I can stack some numbers. And then I'm put a fraction bar, or let's say an addition bar. Not a fraction bar, I'm sorry, an addition bar, like we're going to be adding here. All right, so since you're starting this off, this is something you're going to have to remember. The first number comes down. It's like there's a 0 there. So that's just a 3. Then you take the number in the pocket and you multiply it times this number, 12, and you stack it underneath the next number. Then you add. A negative 10 and a positive 12 is 2. Then you multiply again. You multiply the 4 times the 2, that's an 8. Then you add. 12 and 8 is 20. Then you multiply. 4 times 20 is 80. And then you add, and that would be 58. Now, I can stop because there's nothing left to stack underneath. I'm out of terms. So the very last part is my remainder. So I always circle that. This is my quotient, at least the coefficients. Look back here. That's my quotient, and that's my remainder written as a fraction. That's the actual little remainder there, 2x minus 11. In this problem, this is my quotient, this is my constant, this is my x, this is my x squared. I have 3x squared plus 2x plus 20. See how they keep the order? Right? Descending order. And then I have a positive 58. So I'm going to put plus for the positive, and I'm going to write 58 all over my divisor, which is x minus 4. And there you go. Now, if you don't believe me, you could take x minus 4, put it on the outside, put the whole long fraction process here, and do long division and see if you don't get that same answer. What times x gives me 3x to the third? Well, that would be 3x squared. Then I multiply. Then I change the signs and I add straight down. And I have a positive 2x squared. And I bring down the plus 12x. And then I start all over again. What times x gives me 2x squared? That'd be a plus 2x. Okay? Then I multiply the 2x times the x minus 4. That's 2x to the second minus 8x. Then I change the signs because I don't like to subtract. So I change it to adding the opposite. This becomes negative. This becomes positive. These cancel. And I get 20x. And I bring down the minus 22. And I got to go one more time. What times x is 20x? Well, that'd be a positive 20. 20 times x is 20x. 20 times minus 4 is a minus 80. Then again, I change the signs because I want to subtract here, so I'm going to change to adding the opposite. Yep, that goes plus. And these cancel, and I get, looks like 58, which is my remainder. So that's going to go up over that. See my answer right there? So either way you work it, but this was faster. And the more you practice this, the easier this becomes. There are some things you have to be looking for. You have to be very careful not to make a silly mistake and put something, you know, like forget a placeholder or something like that, or careful with your signs. But it's pretty straightforward. We'll try some more. Next one up, let's see, that was 19. Next one up would be 23. 23 is 9x to the third minus 18x squared minus 16x plus 32, and you're dividing by x minus 2. All right, this has to be in the form x minus the number, x minus a. So a is 2. Now if that had been a plus 2, then a would have been negative 2 because x minus negative 2 would be x plus 2. But it is x minus 2, so the 2 goes in the pocket, and this is already in descending order, no terms missing. Put down the coefficients, 9, negative 18, negative 16, and then the constant term is 32. Leave some space and then put that total bar there. Bring the first number down, then you multiply. Then you add, that's 0. Then you multiply, 0. Then you add, it's negative 16. Then you multiply, that's negative 32. Then you add, that's 0. The last one, that's your remainder, so my remainder is 0. I don't have to write anything down. In this case, that's my constant term. My variable is x. That's my constant term. That's my x term. That's my x squared term. That's my x term. That's my x squared term. So I have 9x squared plus 0x minus 16. Well, you're not going to leave 0x there. That looks kind of ridiculous. 0x just 0. You get 9x squared minus 16. It's not so bad. Again, you have to have it set up so that you're dividing by a linear binomial that is in the form x minus a number, even if the number is a fraction. Speaking of which, number 27. You have 4x to the third plus 16x to the second minus 23x minus 15, and you are dividing by x plus 1/2. Alright, so in the pocket, remember it's got to be in the form x minus the number, so the number is negative 1/2. X minus negative 1/2 is x plus 1/2. Then the coefficients, I got a 4, I have a 16, I have a negative 23, and I have a negative 15. Again, very nice. So far, most of these problems are already in descending order, and there's no missing terms. So leave a space, bring the first number down, and then you multiply. Negative 1/2 times 4 is negative 2. Then you add. That's negative 14. Oops, excuse me, positive 14. Then you multiply. That's going to be negative 7. Then you add. That's going to be a negative 30. Then you multiply. Negative 1/2 times negative 30 is a positive 15. Then you add, and that's a 0, and that's my remainder. So that's my constant. That's my x. That's my x squared. I have 4x squared plus 14x minus 30. The remainder is 0, so I don't have to write anything down. At least I don't think they want you to write anything down. Let's see. Nope, just divide using synthetic divisions, the directions. Okay, three more here. Problem number 31. In problem number 31, it says express the function in the form f of x equals x minus k times q of x plus r of x. That's your divisor. Like back here. This was your divisor. This is the x minus k. I've been using a. This is your quotient. That's this part. That's your answer part. This is the quotient. And then this is your remainder. Not written over as a fraction, just your remainder. Okay? So in 31, they give you k is 4. F of x is equal to x to the third minus minus x squared minus 14x plus 11. There's the 11. And then k is equal to 4. So if k is equal to 4, what you're doing is you're dividing to figure out the quotient and the remainder. We already know the divisor. We already know that this is going to be x minus 4 here for the first part. I just got to get the rest of it. So 1, negative 1, negative 14, 11. 4 in the pocket. Okay, because you're dividing by x minus k. You're dividing by x minus 4. So the 4 goes there. Opposite what it kind of looks like. So the first number comes down. Then you multiply. That's a 4. Then you add. That's a 3. Add these numbers. 3. Then you multiply. That's a 12. Then you add. That's a negative 2. Then you multiply. That's a negative 8. Then you add. That's a positive 3. And I circle that. This part here is the q of x. This part here, the remainder, is the r of x. So what I have here now is that my q of x, this is my constant, my x squared, I get 1x squared plus 3x minus 2. And then plus r of x, so plus 3. And that's what they're looking for. This is your answer. Kind of weird looking, but I think you get 2 of these, don't you? Nope, just the 1. In 35, there are 4 parts, but it's a lot easier than it looks. It says use synthetic division to find each function value. Then it says use a graphing utility to verify the result. Well, I mean, we can plug into a graphing calculator and try to figure out what's going on here. I'll show you what they mean by that, but I'm not going to spend a lot of time with the graphing utility part. In number 35, they give you f of x is equal to 4x to the third minus 13x plus 10. Now notice it's in descending order, but it doesn't have an x squared term. I'm always looking at that when I'm thinking about division. In part A, they want you to figure out what f of 1 is. Okay, what's really cool is a theorem that you have here in this book that is called the Remainder Theorem. And what that means is if you plug 1 in, figure that out. And you could plug it in the traditional way by plugging 1 in here and here. What you end up with is the remainder if you take this and divide it by x minus 1. This x minus 1. Whatever the remainder is, it's going to be what f of 1 is. And I'll show you that. So for f of 1, first they want you to find f of 1. Now you could do it the hard way. You could do this as 4 times 1 to the third minus 13 times 1 plus 10. So this is 4 minus 13 plus 10, which is, what is that, 1? But in the directions, it doesn't say plug in. It says use synthetic division. Actually, it's almost as if we're using synthetic, ready, substitution. Look what happens. I'm going to put the 4 down. Then I'm going to put a 0 down because there's no x squared term. Then I'm going to put the negative 13 and the 10. And my value that I plug in is a 1, so I'll put a 1 here. Bring the first number down, then you multiply, then you add, then you multiply, then you add, then you multiply, then you add. Look at my remainder, the same as that. And that will be true each time, as long as you can use this idea of what they call the remainder theorem. So now it says, use a graphing utility to verify the results. What they mean by that, let's see if I have anything up here. I did grab my graphing calculator here. let me plug in 4x to the third minus 13x plus 10. All right, now watch what happens. Hopefully I have this at a good enough graph here. We'll use standard here. All right, do you see here that when x is 1, gosh, I can't even see it here, my eyesight's so bad. When x is 1, y is 1. You see how it's 1, 1 right there at the bottom? It's almost like the bottom of the graph there, that relative minimum point has an x value of 1 and a y value of 1. If you don't believe me, let's hit trace. And the trace is not quite there. We'll get there. You see how it's getting closer to that point? Looks like I'm almost smack dab at it. Look how close the x and the y values are to 1. Okay? So that point is the 1, 1. Remember, that's your x value. When you plug it into your function, that's your y value. It's like you have the ordered pair 1, 1. Now, that's not what they asked. They want you to use this to find that number. So we'll do that for part B. In part B, they're asking you to find f of negative 2. So I put down the 4. Let's see if I move this up a little bit. The 4, the 0, the negative 13, and the 10. Okay. I put negative 2 in the pocket. And I'll make less of a space there so I can squeeze a couple more bits in here. So I bring the 4 down. Always the first number comes down, then I multiply, that's negative 8, then I add. 0, negative 8 is negative 8, then I multiply, that's positive 16, then I add, that's a 3. Then I multiply, that's a negative 6, and then I add, and that's a 4, and that is my answer. I'm telling you that when you plug negative 2 into this function, you're going to get positive 4. Negative 2 to the third is negative 8, times 4 is negative 32. Negative 32 minus 13 times negative 2, that'd be plus 26. So that'd be negative 32 plus 26 is negative 6 plus 10 is positive 4. You can plug it in and do it as a check. They want to see this, though, in the problem. So for part C, they're asking for you to do f of 1/2, trying to make it tough on you with a fraction. So I put the 1/2 in the pocket. I put the 4 and the 0 and the negative 13 and the 10. So the 4 comes down. Half of 4 is 2. Then you add. Half of 2 is 1. Then you add. That's negative 12. Half of negative 12 is negative 6. Then you add. That's 4. So I'm telling you f of 1/2 is also 4, which is kind of cool. So I have those two values there. And then I have to do part D, and I'm almost out of space here. And I'm trying to find f of 8. So I'm going to put the 8 here. I'm going to put the 4, the 0, the negative 13, and the 10. By the way, don't know if you realize how important that 0 is. If that 0 isn't there as a placeholder, then my numbers are not going to work out. You can see that they change because of that 0 being there. So be very careful on that one. All right, so now, let's see if I can squeeze this in. Bring the 4 down, then you multiply, that's 32. Then you add, that's 32. Then you multiply, let's see, that'd be 64 and 20, 256. Then you add, that's 243. Then you multiply, yikes! 8 times 243, I get 1944. Then you add, and I get 1954, and I circle that, that's my remainder. So this is equal to 1,954. Didn't take long for that number to get big. All right, so that's how you do number 35. Okay, I'm going to move this. There's one problem left, and I'm almost out of paper. I got some line paper here. And that is problem number 39. Number 39, they give you x to the third minus 7x plus 6 is equal to 0. Now it says here, use synthetic division that show that x is the solution of the third degree polynomial equation. and then use the result to factor the polynomial completely. List all real zeros of the function. Now we're getting to it. This has got some steps. It's not terrible, but it's got some steps. So the value of x that they give me in problem number 39 is that they give me a 2. Pretty soon they won't give you the 2. You're going to have to figure out some rational zeros and then experiment by using synthetic division. But for right now, they're telling you that that's a 0 of that function, or of that equation. It's a root to that equation. Your function would be f of x equal x to the third minus 7x plus 6, because they're asking for the zeros of the function that correspond. So first things first, I'm going to go ahead and put the 2 in the pocket, and then I'm going to have a 1 from the x to the third. Now there's no x squared, so a 0, and then the negative 7 from the x, and the 6 is the constant term. Got to be descending order, got to have those placeholders, put the total bar. So the first number comes down, that's a 2. Then I add, that's a 2, that's a 4. Then I add, that's a negative 3. Then I add, or multiply here, negative 6, and then I add, and that's a 0. Notice that my remainder is 0. What that means is that x minus 2 divided into x to the third minus 7x plus 6 evenly, because the remainder is 0. In fact, if you want to think of it, it's like x minus 2 divided into x to the third minus 7x plus 6 as remainder 0, constant x squared, as x squared plus 2x minus 3. That's the quotient. But what you can do here, because the directions ask for you to use this result to factor the polynomial completely. Well, this times this gives me that, because I divided it into it, and these are my two factors, and that's my product right there. So what that means is, let's go back to the problem, x to the third minus 7x plus 6 equals 0. That's x minus 2 times all of this. X squared plus 2x minus 3 equals 0. And you're done unless it factors further, and it does. So this is x, and this is an x, and this is going to be, looks like a plus 3 and a minus 1. So if I go ahead and solve, I'm going to get 3 answers, one of which we already know. We already know the 2. And that's what happens here. I get x equals 2. Here I get x equals, subtract 3 from both sides, negative 3. Add 1 to both sides on this one, I get x equals positive 1. So the question says, use the result to factor the polynomial completely. So that's this right here. Okay, I factored it completely. And then it says list the zeros. The zeros are 2, negative 3, and 1. And you can put them in order from least to greatest if you want to. But that's the zeros right there. Now that's kind of a big deal. You divide something into a polynomial into another polynomial. If it goes in with the remainder 0, it's a factor. It divides into it evenly. X minus 2 divided into this guy right here, x squared plus 2x minus 3 times. So this times this is going to give me the stuff underneath. You kind of did that when you were first learning long division. You could check your answer by multiplying the dividend times the quotient to see if you got the divisor times the quotient to see if you got the dividend. All right, and that's how that guy works. Now, those are your problems for practice and such. Probably wouldn't kill you to do a couple more just to make sure, but I'll have in the next video some problems for you to review for your quiz that's coming up. Practice, practice, practice.